Okay, so now that you guys have gone over what the parent function is, okay, our cube parent function or our cubic parent function, remember that it has the 5 points, -2, -8, -1, 1, 0, 0, 1, 1, and then 2, 8. Okay, now that we know we have our parent function here, the last thing we have to do is we have to cover all the different shifts that can happen with this. So we need to remember our inside causes the horizontal shifts. And remember that if you are inside of prison, that is because you have been doing the opposite of what you are supposed to do. Okay, so when we have things on the inside, if they look like they're supposed to go to the right, they actually go to the left. Okay, and then also for outside, that would be your vertical shifts. And if you are outside of prison, you are doing what you're supposed to do. So if you see a plus sign, you are going up. Okay, it's only the inside that is horizontal. And then I also like to add in here about the negatives. Don't forget that with your negatives, they are going to cause these things to flip. They follow the same rules. If the negative's outside, it flips vertically. If the negative is inside, it flips horizontally. Okay, now this is going all the way back to when we started with our parabola. So looking at things that are on the inside here, just like with our parabola, if I had y equals x minus 2 squared, that minus 2 is on the inside, so that would cause a shift to the right too, because the inside we do the opposite. So just like with our parabolas, anything that is on the inside of parentheses, if it is inside of parentheses, it is going to cause your horizontal shifts. If there is something out in front of the parentheses or added or subtracted back behind, those are going to be your vertical shifts. So this is one that we've seen before, so this should be very, very similar, okay, to our parabola that we've done. Just a different parent function. Let's go through a couple of these examples here. So I have y equals x cubed minus 3. Excuse me. I will start out with this one here with my parent function. The parent function is just y equals x cubed. So I've got 0, 0, 1, 1, and then 2, 8. And I've got -1, -1, and -2, -8. I'm just going to check to make sure. Good. So there is my parent function. Yeah, that's pretty good. Okay. Now the next thing I'm going to do here is I've got that -3. So where is that -3? Is that on the inside or is that on the outside? And hopefully your answer is that that is on the outside. Why is that on the outside? Well, because there are no parentheses. Ooh, did not spell very well there. There are no parentheses on that, okay? The only way it can be on the inside is if it is inside of parentheses. Now, if we're on the outside, we do what we're supposed to. So each of these points is now going to shift down 3 spots. And then this one is one more spot off the graph, so that's not too bad when we are drawing this. So there is our cube function shifted down 3 spots. And again, it is down because it is outside. If this would have been a plus sign here, then it would have moved up 3 because again, it's still on the outside, okay? But we always do what it says on the outside. So that plus would mean that we are going up. Okay? So let's try an example of a horizontal shift. Okay, again, we start with our same parent function. Notice it's cubed, so that means my parent function is y equals x cubed, 0, 0, 1, 1, 2, 8, -1, -1, -2, -8. We go up, and we go down. Okay, now, I told you guys that this was a horizontal shift. How do I know that this is a horizontal shift? Well, look at that -3. That is horizontal because it is inside of parentheses. That is horizontal because it is on the inside of parentheses. So I have y equals x minus 3 cubed. Okay? Inside, we always do the opposite. So even though negatives make me think I'm going to the left, each of these points are actually going to shift to the right. 3 spots. So each of my points shifted to the right 3 spots. So there is an example of a horizontal shift. Again, like last time, if that was a +3, the only difference is it's still on the inside. We just would move it to the left 3. Okay, we just do the opposite there. We got one more example here with a negative. Okay, so we will start off with our parent function, y equals x cubed. So I've got 0, 0, 1, 1, and then 2, 8. And I'm going to change colors just so we can make sure we see how this switch happens here. I also have a -1, -1, and a -2, -8. Okay, so again, there's my same parent function. Now this is a negative, and negatives cause things to flip. Okay, so negatives flip. Now, where is that negative at? Well, that negative is inside of your parentheses. So since that negative is on the inside, that means we're doing a horizontal flip. So whatever's on the right will flip over to the left. Whatever's on the left will flip over to the right. So when this thing flips, now this side is going up, and then this side down here is going down. So you guys can see how those have flipped. That is a horizontal flip. If there was no parentheses, it would be a vertical flip. So the top part would flip down and the bottom part would flip up. Okay? Now, one more. We have just a couple shifts on here that we can do. So again, we will start with our parent function, y equals x cubed. So we've graphed this 4 times. Fisher always wants to know why we have to graph them so much. It's because it helps him to memorize them. So I've got my parent function there. Where is this -5 at? Well, that -5 is on the inside, and I know it's on the inside because it's in parentheses. So I will shift each of these points over 5 spots. Inside is horizontal. Shift each of these points over 5 spots. Did not go down far enough. Sorry about that. Oh, that was... Sorry, I'm struggling. I need to be one more over. Right about here. There we go. Okay, and then the last thing I have is I have that negative there. Okay, and where is that negative at? Is that negative on the inside of the parentheses? No, that negative is on the outside. Negative is on the outside, so that means we are going to do a vertical flip. And that means that this stuff that's up top will flip down. Okay, so whatever was up top has now flipped down. Okay, and then whatever was down below has now flipped up. So there is a vertical flip of our cube function. There are more of these practice problems afterwards. Like I said, we are taking a slow quiz next class time over these parent functions, so it would not be a bad idea to roll through and practice each of those. I will be in my room and help you guys practice with those. Other than that, there's a really cute picture of my pup.